Good morning. We are live, and this is Math 60 Intermediate Algebra, Chapter 6.1, Woohoo, Rational Functions, otherwise known as if you didn't like polynomials, you'll love dividing them. Okay, a rational expression is an expression of the form, and let me say, this is just lazy, whoever wrote this up, seriously. A over B, where A and B are polynomials, and of course B is not equal to 0. That's going to be really important. You don't want to be in the middle of a math problem and start blowing everything up. So examples of rational expressions, they can be as simple as you'd like. For example, technically speaking, x over 1 technically qualifies, although we would probably, people would probably be a little cranky about that. Better examples would be 1 over x. This is starting to get meaty. You've actually got something interesting in the denominator. And then we can go, completely bonkers. There we go. I don't know, my brain is not very thoughtful today. X to the 14th minus 3x squared all over 6x to the 49th plus 3. I'm going to be really careful with my dividing line there. Basically, you put a polynomial on top, you put a polynomial on the bottom, and you see what kind of shenanigans they get up to. So, simplify and note any restrictions. So restrictions is this concept where in math, we're going to say, sure, anyone can come to the party, but we all agree that certain things just cannot happen. And so those are what the restrictions are. It's like a warning label on your polynomials or on your rational expression that says, well, just don't let this crazy kid be 5, because then life gets hard. So let's look at what's going on here. If I've got 3x squared yz all over 3x y squared, a couple things are happening. I've got an x and a y in the denominator. There's a single term here. So if either x or y is 0, we multiply by 0, the whole denominator becomes 0. So first, right off the bat, I'm going to say, don't let x be 0. Don't let y be 0. Those are our restrictions. The restrictions are basically what we're doing is we're restricting the domain, or we're restricting what variables can be equal to. So x can't be 0, y can't be 0. Okay, let's keep going. Now, if I look at this, I see that I have a 3 top and bottom. I have a y top and bottom. I have I don't have a z, that's a z, that's a y squared. I have an x squared. So, you know what, to make it easier, I'm going to do this. I know this is moving backwards a bit, but let me show you what's actually happening. For those of you, some of you are looking at this going, wait a minute, I see exactly what's happening here. Let me pull out my blood red. Ooh, bringing in the blood red. I specially order these because they look closer to blood than the usual red pen. And interestingly enough, I'm all out. Here we go. Endless supply of these G2s. Love them. 3, cancel. Oh, it doesn't show up as red. Oh, well. X, cancel. Woohoo. Y, cancel. Z, cancel. Basically, everybody cancels except for an X on top and a Y on the bottom. Woohoo. Yeah, it looks like, sadly, yeah, it looks like my red doesn't really show up on camera. I'm going to have to find a new red pen. Oh, sad. Okay, we'll just leave this as kind of an existential question over here. People who are just reading the notes would be like, what does this have to do with the math? Everything. Everything has something to do with the math. Now, I want to show you the power of restrictions here. So I said to begin with, don't you dare let x equal 0. In the end result, there's no reason to think that x equals 0 would be a problem, because we went through the canceling, x has now disappeared. So this is why restrictions are really important, because this is kind of like a family curse. way back, your great-great-grandparents did something, kicked a gnome. Not that I don't like gnomes, but let's just say they kicked a gnome accidentally. They're small. They're in the garden. You don't see them. I mean, you'd think you'd see them with the red hat, but if the red looks like this, you're not going to see them. So your great-great-grandparents kicked a gnome. And so now there's a curse. The curse comes all the way down to you. And even though you did not kick the gnome, you still have to follow the rules of the curse. That's the same thing. Basically, if x can't equal 0 to begin with, x can't equal 0 here. So we would actually say, don't let x equal 0, don't let y equal 0. And then everyone would say, ooh, you must have been under a curse because there's no other reason why x could not be equal to 0. So people understand that if it still has these restrictions, even though the expression doesn't seem to warrant it, something interesting must have happened to your great-grandparents. Shall we move on? Let's move on. Okay. This one, oh my gosh, this is the bane of the existence of most people I know. This is what happens when you've got a rational expression and you've got more than one term, top or bottom. So here's the thing. It looks really, 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 it looks great to just take the 3x squared and the 3x and just cancel, just draw a line through. You can't do this. If there are two terms, you can only cancel through factoring. I know this seems so cumbersome, but it is the only way to do it properly. It is not fair to start just canceling randomly. You will end up with a rational expression that is not the rational expression you started with. So let's look at what the heck this means. 3x squared all over 3x plus 3. Up on top, it's one term, so it's already factored. Down in the bottom, I see 3x plus 3. I can factor out a 3. And I get 3 times the quantity x plus 1. I just factored out common factors. So then I look at this and I go, oh, well, this isn't this thing. This is 3 times x plus 1, which means I can cancel the 3's. Since the red is not showing up, which again is a tragedy, let me try a handy dandy yellow highlighter. One of these days, they're going to invent a highlighter that truly doesn't smear. I mean, it would probably, cause hemorrhagic fever, but I would still buy it if it didn't smear. So the 3, they can actually cancel. So we end up with x squared all over x plus 1. So far, so good. Now you're all saying, yes, but you got so excited about the factoring you forgot to do the restrictions. I know. The great thing about math, though, is except in a video when you're watching which order I do it in, if you do all the factoring and you get all excited and then you're like, oh no, restrictions, you can go back up here and write the restrictions, and there's no way I can carbon date to see which one came first. So, otherwise, if I were just in the old days, I could have just write it up for you in the notes, when we were doing it in cuneiform on clay tablets. I would have done the restrictions up here and you guys would never know. Of course, I would have to cook it for a day, and then we would have to very carefully hand it person to person to learn the math. All things considered, I appreciate video now. Okay, so I have got for the restrictions, I look at my rational expression, and it's a rational expression, which means I have a denominator. And I want to make sure that 3x plus 3 does not equal 0, because that's the denominator. So in order to do this, and this explains a lot about mathematicians, if you have any pet mathematicians at home, when we're looking for when it isn't equal to 0, the easiest way to find that is to find out where it is equal to 0. See how that works? So I'm going to go ahead and say, okay, 3x equals negative 3. You probably figured this out. Uh-oh. My past and my future are interacting. My spatial awareness, really, you think math teacher, we have great spatial awareness. Not at all. Not at all. In fact, you can't see, but even though I'm sitting, I'm currently also tripping right now. Falling down, not that kind of tripping. I meant trip, never mind. Oh my goodness, this is hard. Okay, so it's too early in the morning and I've only had one cup of coffee, which is really not enough for this. X equals -1. So what the heck? Let's go back up here. What was I looking for? I was looking for when the denominator here was equal to 0 so that I can make sure that it's not equal to 0. So my restriction is don't let the pigeon drive the bus, and also don't let X equal -1. So here's my answer, my final answer. I'm giving myself extra space, and don't let X equal -1. Now, the thing about this restriction is it's still obvious in the rational expression. We can already, anyone looking at this goes, yeah, if X were -1, then we get 0 in the denominator. That's a problem. So we're going to have kind of two different situations. One, well, many different. Wait till you find out the horrors in this chapter. Truly, division, not one of my favorite things. But there's the possibility that your restrictions will seem goofy because, see, like I said, I'm seriously, I am clumsy even when I'm seated. Oh, okay. X can't be 0 even though it's not obvious here. Other cases where the restriction is obvious from the problem itself. So sometimes you will cancel out the problem causing the restriction. Sometimes you won't. Doesn't matter. A curse is a curse. You have to keep it in the answer. Okay, woohoo, that was page 1. Oh man, this chapter is going to go so well. Yay. Okay, let's do page 2 because I'm only at 11 minutes and 32. Oh my gosh, the seconds keep changing. So. And there are gulls outside my house because I don't know why. I live nowhere near the ocean. Okay. Wow. Now's the time when you're going to be so glad that we just did chapter 5 because chapter 5 was chock full of factoring. Notice I have more than one term. In a rational expression. Look at all this spelling I'm doing. This is amazing. More than one term in a rational expression, you must factor. Dun dun. Or else the world ends. Truly, the world will end. If you go in and try to cancel the X's just the way it's so wrong. It's so wrong. Your cat will dislike you, which I imagine your cat might not think much of you now, but will truly dislike you. Other people's cats will also dislike you. When you walk through the world, you'll sense that there are cats inside of houses thinking, oof, there's someone outside I do not like. So you don't want to live with this, really. You should factor. So 3x squared minus x minus 2, oh joy. So let's see, I got a 3x. I'm doing trial and error here because that's what I know how to do. You can use the AC method. You can use the X method, the lattice method. You can use aliens. You can use whatever you'd like, really, right here. I got 3x. I got to get to -2. So let's see. I think I've got, end up with a -1. So I think there's going to be a -1 here and a +2 there. Let me check. -3x plus 2x. Yes. Okay, so that was, you need to factor this. Now, if you need to pause the video and take a look at why this factors this way, go ahead. I'll wait. I'm not actually going to wait. You pause the video and then, time can pass in your life, whereas I can just start up again. So I'm going to start up again, but you should pause it and do this. Go on, do it. Seriously, do it. Okay, so now I have to factor the denominator. Now I'm thrilled. This is a difference of 2 squares. So I've got x plus 1, x minus 1. So I'm going to factor each of the polynomials. Now, you don't have to write them separately. If you know how to factor them by sight, that's great. I just wanted to give a little bit of space for that. Okay. Now I take a look at this and I say, oh, wait. With these all factored, I see they have something in common. Okay, I'm blowing on it so that less smearing is the goal. There we go. X minus 1, they match, they cancel. So I've got 3x plus 2 all over x plus 1. And you're all going to say, wait, yet again, you forgot to list the restrictions. And the answer is, well, yes, I did. But the reason for that is that when things get more complicated like this, I wait till the end to do the restrictions, because look right here. There are the restrictions. And just like in chapter 5, if you've got x plus 1, you got to set that equal to 0. I don't know if you can hear that, but those are my cats walking around. They're not walking around, they're swarming. They're swarming like sharks, because that's the word you use for sharks. When sharks swarm, they're swarming me because they haven't had their mid-morning snack. Okay, so that's what you're hearing. They're tearing things up. They realize I'm attached to this video and I don't seem to want to leave, so they're just enjoying tormenting me. Obviously, I was not careful with my factoring at some point in my life, so cats have a a slight vague dislike for me. They remember I didn't factor correctly. So my restrictions, which I get from both of these, are that x can't be -1 and x can't be 1, right? X equals -1 makes this part 0. X equals 1 makes this part 0. So I'm going to say x is not equal to, and ready for this? Look at this flare. That's how you can tell I'm a professional. In fact, another thing that I know to do, I can double box it, and then it looks so much more professional. Look at that. Wow. So x is not equal to plus or minus 1. Only one of those are visible because we did cancel the other one right here. Oh man, we got one more. Dun, dun, dun. This is so exciting. And you think that chapter 6.1 will be done. No. We've got a couple more pages. Okay, 10x plus 10 all over 5. And then we look at this and we're like, oh no, 2 terms. 2 terms means factor. Okay. So I'm going to factor the numerator, and I'm going to get 10 times the quantity x plus 1. That's a common factor there. Again, pause the video if you're not sure and look it up. Figure it out. In kind of a weird form of inception, you could pause the video and text me, and we can discuss why this happened, and then you can start the video again. And I won't even know it right now. I don't know if you will have texted me in the future. And I think I'm running out of tenses so I'm going to stop because I don't know my future pluperfect. Okay, my future past pluperfect, whatever it is. Okay, I factored. X plus 1 does not have any buddies here, and so I can't cancel it. However, the 10 and the 5 do. The 5 goes into 5 once, the 10, it goes twice, and here's where things get interesting. If I cancel everything out of a numerator or denominator, what's left? You got it, 1. Now, if the 1 is left on the bottom, it's like the whole thing. Like if you've ever tried to balance a whole bunch of stuff on a stick, that's not going to happen. It falls over. And so you end up with just 2 times the quantity x plus 1. Now, what are the restrictions? There are no restrictions. Why are there no restrictions on this one? Well, the only thing in the denominator was a 5. 5 can't be 0. Life is great. This is what we learned today. If anyone says, so what'd you learn at school today? Tell them 5 is not 0. They'll be very, very impressed. Ooh, we must be done with our video now. Okay, I'll see you guys in either an hour or 15 minutes or I don't know, whenever you start the next video. Have fun.